This is a video on multiplying binomials, but specifically on two special cases that you'll run into on occasion. So when you see that two binomials are very similar, but the only difference is the sign is different between them. So there's one with a plus and one with a minus. Okay, so this first example and this second example, everything is exactly the same except for the sign in between them. One is positive, one is negative. When that happens, these are conjugates. Now, if you truly understand the process of doing this, we're going to have four multiplications to do. We're going to have the x times the x. We're going to have the x times the negative 4. We're going to have the 4, positive 4, times the x. And then, need one more color. We're going to have the 4 times the negative 4. Now, when and only when the values here are conjugates, I shouldn't say only when, but when the values are conjugates, every single time the two middle values are going to cancel out. See how we have a negative 4 times x, which would give us a negative 4x, and then a 4 times positive x here would give us a positive 4x, right? So the middle terms here of negative 4x and positive 4x will always give us 0. So we're really going to only focus on the green and the blue to give us x squared minus the 4x plus the 4x minus the 16. The two middle terms are going to cancel, give me 0. So the end result is x squared minus 16, which is called a difference of squares. Okay, difference being the minus, x squared and 16 being perfect squares. Okay, when we look at that same process here, first it starts with recognition. Are these conjugates? Yes, they're the same first term, they're the same last term, they have different signs. So the quick way to do this is we're going to multiply 3a times 3a, which gives me 9a squared. We're going to multiply 1 times 1, which gives me 1. And we know that positive times negative is negative. And we get our difference of squares because the middle terms cancel out. Very different than when you have to square a binomial. The biggest mistake I see after Algebra 2 is that people forget that there's a middle term here. You need to know that this squared means you're multiplying by itself twice. There are 1, 2, 3, 4 different chunks to add together. We do a times a. We do a times b. We do b times a. And we do b times b. These two things, although they look like they're different, multiplication is commutative, so I can change the order of either one. So it's really a squared plus 1ab plus 1ab, switching the order of the second one. And then I now have two of those, so I have 2ab plus b squared. This is the result of squaring a binomial. In this case, a plus b squared. Now let's apply that and use a shortcut, because we all love our shortcuts, to a different one. Let's go 7y minus 3 squared. So we have a plus b squared. Let's just make this a little bit easier just to kind of transition into it. Changing this to a positive so it matches up nicely. I'm going to take this, which represents a, and I'm going to square it. So 7y squared is 49y squared. So square the 7, square the y. I'm also going to take the 3, and I'm going to square that, leaving a lot of space for the middle term. We're going to multiply a and b. So in this case, a and b are just a and b. Here, they are 3 and 7y, which if I multiply, I get 21y. And I'm going to need 2 of those. So put 2 of those in there, double it, and you get 42y. There is my perfect square trinomial. Okay, so I'm going to shrink this down, and I'm going to try that again. Let's go with 3x minus 9 squared. Okay, a squared and b squared are easy. We're going to do this here. We're going to do that there. So I'm squaring 3 and x, which gives me 9x squared. I'm squaring a negative 9. Negative times negative, always positive. I'm going to multiply the 2 values. 3 times the negative 9 is negative 27. Keep any variables. And then double that. 2 times negative 27 is negative 54x. And that's how you square a binomial.